All right, welcome back to our cloud computing course. For lecture 15, we are getting our hands dirty with OpenStack. This is the powerful open source platform that lets you build your very own cloud. If you've ever wondered how you could set up a private infrastructure as a service environment from scratch, well, you're in exactly the right place.
Okay, so here's what we've got on the agenda today. We're going to start with the big idea, what OpenStack really is. Then we'll meet the key players, the core services that make it all tick. After that, we'll get real clear on the different ways it handles storage, watch how all those pieces come together to create a new virtual machine, and then we'll wrap it all up with the key takeaways for this lecture.
All right, first things first, let's talk about why a platform like OpenStack is so important. It's more than just another piece of software. It really represents a fundamental shift in who holds the control over cloud infrastructure. And really, this question is everything. It's the whole reason OpenStack was created. We're talking about moving past just renting servers from the big guys. This is about giving you the power to build, to manage, and to completely automate your own infrastructure. You know, the easiest way to think about OpenStack is that it's basically the Linux for your cloud. It's a whole suite of open source projects that gives you all the building blocks you need to create your own IaaS cloud, without paying a dime in licensing fees. This makes it perfect for things like academic labs, research projects, or any company that needs total control over its environment. Okay, so let's peel back the layers here. OpenStack isn't just one big piece of software. It's actually a collection of different modular services that are all designed to talk to each other through APIs. So let's meet the main players on the team. So these are the big ones, the heavy hitters that make up pretty much any OpenStack setup. Each one has a very specific job to do, and understanding how they interact is key. So let's get to know them, one by one. So first up is Nova. This is really the heart and soul of the whole operation. It's the compute engine. When you click that button to ask for a new VM, Nova is the service that kicks in a gear, figures out the best physical server to put it on, and then actually brings that VM to life.
Right, so you have a VM. Now what? It's not very useful sitting in a dark room by itself. That's where Neutron comes in. It handles all the virtual networking, creating private networks, assigning IP addresses, setting up routers to make sure your VMs can talk to each other and to the outside world securely.
Now for storage, we have a few options. Let's start with Swift. Think massive. Swift is all about storing huge amounts of unstructured data, things like video files, backups, or website assets. It's not a traditional file system. It's built for extreme durability by automatically making copies of your data across the cluster.
Okay, this is a really key distinction. Cinder gives you what we call persistent block storage. If your VM's own temporary storage is like its short-term memory, a Cinder volume is like a USB hard drive you plug in. You can attach it, store your database on it, and even if you delete the VM, that Cinder volume, it sticks around.
All right, every cloud needs a gatekeeper, right? For OpenStack, that's Keystone. Think of it as the bouncer or the security guard for the entire cloud. Before any other service does anything, it checks with Keystone to ask, hey, is this user actually allowed to do what they're asking to do? Okay, so when you spin up a new VM, you're not installing an operating system from scratch every single time. That would be crazy slow. Instead, you're using a template. And Glance? Glance is the library where all those templates, or images as they're called, live. You want an Ubuntu server? Glance has the image for that.
Remember way back when we talked about the core principles of cloud computing? One of them was measured service. While Ceilometer is how OpenStack gets that done. It's the service that keeps track of everything, CPU hours, network usage, storage consumed, so you can bill users or just keep an eye on performance. And last but not least, we have Horizon. You know, all this command line stuff is great for automation, but sometimes you just want to point and click. Horizon is that friendly web dashboard that lets you and your users manage the cloud visually, launching VMs, configuring networks, all from your browser. Okay, so we've mentioned Cinder and Swift. Let's really hammer home the differences here, because this is super important. There are basically 3 flavors of storage in OpenStack, and picking the right one for your application is absolutely everything. Yeah, this chart breaks it down beautifully. You've got ephemeral storage managed by Nova itself. Think of that as scratch paper. It's fast, it's right there on the compute node, but when the VM goes poof, so does that data. Then you have block storage from Cinder. That's your persistent virtual hard drive for databases and important files. And finally, object storage from Swift, which is for data that isn't tied to any one VM and needs to be accessible from anywhere. All right, we've met the whole team.
We know who does what. Now for the fun part. Let's see them all work together to do the most common thing you do in a cloud. Launch a brand new virtual machine. This is really where you see the magic of this whole modular system. It's a beautiful dance between all these different services, all kicked off by a single request from a user. Let's trace the journey from a click in a dashboard to a fully running server.
Okay, pay attention here because this sequence is a classic. It all starts with you, the user. You ask for a VM, but nothing happens until Keystone, our security guard, checks your ID and says, yep, you're allowed to do that. Then Nova's scheduler finds a physical home for the VM. Next, Neutron steps in to set up the networking and give it an IP address. Only then does Glance grab the OS image, often stored in Swift, and deliver it to the host so the hypervisor can finally boot up the instance. See the flow? Each step depends on the one before it.
Okay, let's bring it all home for Lecture 15. We've talked about a lot of different services, but how does this all tie back to the core cloud principles we've been learning about all semester? Let's connect the dots. And here it is, all laid out. This is your cheat sheet for why OpenStack is a true cloud platform. You've got on-demand self-service thanks to Horizon. You've got resource pooling of all your hardware. Keystone provides that secure multi-tenancy. Ceilometer delivers the measured service. And the entire thing is designed from the ground up to be scalable and automated through APIs. It checks all the boxes.
So I want to leave you with a final question to think about. In a world where a few big public cloud providers seem to run everything, what's the point of something like OpenStack? I think its critical role is for private clouds, for research, and for any organization that needs absolute sovereign control over its data and its infrastructure. What do you think its future holds? We'll see you in the next lecture.